Covalent compounds are nonmetal compounds. They share electrons. In a covalent bond, the goal, what makes atoms most stable, is if they can get 8 valence electrons or an octet. Of course, hydrogen and helium just need 2 helium valence electrons. We can tell how many valence electrons an element has by its position on the periodic table. And of course, we're looking at the nonmetals, and hydrogen's right there, so we'll put a 1 there. And then it does go 2, but these are metals. This is 3, 4, 5, 6, 7. So all of these halogens have 7 valence electrons and so forth. Okay, that's how many we get. So the valence electrons are what do the bonding. And when we start drawing these structures, we're only going to draw the valence electrons. So let's just say, for example, we want to do a Lewis dot structure of fluorine. We see that fluorine has 7 valence electrons. And so I draw those like this. They're kind of in pairs on each side, and then fluorine only has 7, so there's one that's not a pair. When we do this, we kind of have some standard positions that we use. And you can imagine that it's kind of on a box like that. So if we're imagining that being there, they kind of line up on that box. Those are kind of the standard 8 positions. Now we will be moving them from those. They're not always going to be on those positions, but that's kind of how we start off. Okay, let's look at an example of one forming a bond. Something forming a bond. I'm going to zoom in a little. Okay, so chlorine, it's a halogen. It has 7 valence electrons. Okay. Yeah, I wish I had used a different color. I'm going to use a pink here just to make it so we can see what's going on. So, of course, they each have 7, and so what happens is they come together. Okay, and now they each have 8. So those two, these two, are the shared pair. And electrons are always shared in pairs, that you never share one. And one shared pair is 1 bond, or we would say it a single bond. A single bond. And so that's what a bond looks like. This I'm going to scooch out a little. This line, that represents 2 electrons that are shared and single bonds. So it means the same thing to draw a dash. Okay, and on this one I'm not showing all of the ones on the outside, but let me go ahead and add those. So I could show those out here. When you do your Lewis dot structures, we're going to draw all of those for now. Okay, we call that pair, this pair, we call that a bonding pair of electrons. As opposed to these out here, we call those lone pairs. Okay, so just some terminology for talking about these structures. So a bonding pair, lone pair, we said that. A dash represents 2 electrons. Okay, and then I have these steps here. These are also on a slide in your lecture. I'm just going to go through these, but they're here to, I'm going to go through examples, but you can refer back to these as you need to. Let's go through some examples. Let me just start here. Okay, so this one's really simple because it just has 2 atoms. So what you do is you start with a skeleton, and then you say, and so just start with single bonds, connect them together, and then you say, well, how many valence electrons does this have? And if we look on the periodic table, each fluorine has 7 valence electrons, and so since there's 2, I'm going to have 14 valence electrons. Okay, and now I'm going to start adding my valence electrons to this dot structure, and I you always add to the outside atoms first. This one doesn't really have an outside atom because there's just a pair, but anyway, so I just start adding them, and when I start adding them, I try to use up the positions so that they each have 8, and then I check and see if I've used them all up, and I have. So I have 8 and then 6, that's 14. Okay, and so let me just show you how I'm counting those. These electrons, and remember there's 2 right there, those electrons are all with that fluorine. And if I do the same thing with the other side, all of those electrons are with this fluorine. So those 2 get in the middle, the bonding pair get counted twice. So now I would say both fluorines have an octet, and so that's a good Lewis dot structure for that one. Okay, let's do one a little more complicated that has different elements in it. Okay, when you draw the skeleton, always put the atom that is different in the middle. In other words, I have 2 hydrogens and 1 oxygen. So oxygen goes in the middle, and I'm going to start with my hydrogens on either side. You could put them pointed different ways, it doesn't matter. I mean, if you wanted to start like this, you could. But just use the 4 sides for now. Okay, and then I'm going to check how many valence electrons I have. Hydrogen has 1 and oxygen has 6. So 2, 6, that gives me 8 valence electrons. When I put my valence electrons on, I always start with the outside atoms. So on this is a kind of another term we use. These, this is the central atom, oxygen, and these atoms, I say outside, but sometimes they say surrounding atoms are the ones on the outside. Okay, anyway, so you always start putting your electrons on the outside atoms, and I have 8, but you know what? Hydrogen doesn't need any more because it has 2. This single bond has 2 electrons, so that hydrogen has enough electrons. Same with this one. And then, well, how many electrons do I have on there already? Right now I have 1, 2, 3, 4. So I've got to put 4 more on, and they have to go on the oxygen. I'm going to pair them up on the kind of the sides like that. And then I'm going to check and make sure oxygen does have 8. Because we count like that. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like everybody has their octet or whatever they need. Okay, again, different goes in the middle. Start with single bonds. And let's see how many valence electrons we have. Bromine has 7, that's 28, that's 32. Okay, and we're going to start putting the rest of them on. How many do I have on right now? How many do I have on there right now? I have 2, 4, 6, 8. A line, each dash is 2 electrons. So I'm just going to start putting them on and see how it comes out. Put them on the outside first. Make sure everybody gets their octet. Okay, and then I better count and see if I've used all the electrons. I need 32, and I have. So if you want to count those, it makes it kind of easy to count them when you count them like this. That's 8, 16. So I can see it's 4 times 8, so that is 32. I lost an electron. We are going to come back to these and assign shapes over here on the right, so I'm kind of trying to leave some room. Okay, let's do another one. So, and by the way, you guys, it's really easy to watch me do these. It would be good to kind of practice this again on your own and see if you can do it by yourself. Okay, so I started with my skeleton. The different one goes in the middle. Put all single bonds. Let's check how many electrons that I need. Nitrogen has 5 and hydrogen has 1, so 3 times 1 looks like I need 8 valence electrons. Right now I have 2, 4, 6, so I've got 2 more, and I start with the outside atoms first. But all of these hydrogens already have enough because that bond counts as 2. That's all hydrogen needs. So I've got to put 2 more electrons on, so I put them on the central atom. So whenever you have electrons, put on the outside, and if those are full, you put any left on the central atom. Okay, and then if you want to check, hydrogen we know is good, but nitrogen, it has 2, 4, 6, 8, so it's good. Okay, last one of these. This one's a simple one as well because it's just 2 atoms, so I don't really have a central one, so to speak. Okay, let's look at how many valence electrons I have. Chlorine has 7 and oxygen has 6. But what does this charge do to it? Well, it has a negative charge because it has an extra electron. So that's going to make me add 1 more to this. So I'm going to have 14 valence electrons. On this one, I don't have a central atom, so I'm just going to start putting them on. 1, 2, 3. Let's see, that's kind of how I want to do it because they would each have 8. Let's make sure I haven't gone over. That's 8. 6, that's 14. Okay, and then you guys, this is a polyatomic ion, so I need to put brackets around it and put the charge overall.